Hello, this is Graham from Grahamophones, and I thought I'd do a short-ish video on a further video on Garrard motors. We looked at the servicing of the Garrard 14 in a recent video, which is typical, but it really lacked a number of things. One, it showed one system that Garrard used of controlling the speed using the spindle that would rotate, but there are variations on that. It also showed one system of spring case lid fitting, and that doesn't cover every eventuality as far as Garrards. And also, perhaps more importantly, I mentioned and explained a system that I use for setting the speed on that particular motor, and that could be applied to other Garrard motors, but as it's not really a recommended system, in fact you will find on the internet it really is taboo because so many things can go wrong with that. And as I've already mentioned, I tend to do that and feel I'm in control, and it is for me an easier system and gives me the end result quicker, but is not without risk. So I thought I would explain a little bit about how you could do this, how you could do that process of setting the speed, or setting the governor armature position, I should say, using the safer method. Right, so without more ado, let's get cracking. Anyway, let's first of all look at the motor that I'm going to be basing this video around. This is the Garrard number 50 motor. It's come out of an HMV. It's come out of a Columbia 202 from the late 20s, and is a more substantial motor altogether than the 14. It differs in a number of respects. First of all, instead of having one of those tin lid caps to the lid case, this has got a gear that's been used as the lid, and you can see around the edge there are screws that fix that. So removing the spring from that, or removing the cap from that, isn't the ordeal that it would be with the 14 and with some other similar capped tin lid capped spring cases. Coming to the way the pad, it's called a friction pad. It's really, friction is the last thing you want there. It's stopping it's limiting the movement of that disc as it's pulled in with the inertia of the spinning weights there. But friction isn't what you want, because you oil that to cut that friction down. But nevertheless, it seems to be a little bit of a misnomer that's commonly used, but nevertheless, you know what I mean by it. That's it, the friction pad there. Now, on the 14, that was adjusted by a spindle that went either forwards or backwards, and those of you who've seen that video will remember we set that centrally. With this is a bit like the HMV one. It's spring loaded, and the adjustment comes from a vertical screw on the controller arm of the motor board that pushes that down against the tension of that spring to the point at which it is adjusting the speed of the turntable to the required 78 when the pointer is pointing at 78. So unlike the 14, there's not a lot you can do with the setting of the speed of this, the number 50 motor, out of the gramophone. Some ways that's a little bit of a blessing. The other thing to mention is the common feature of Garrard motors, and that is the armature position. Now, I don't know if I can manipulate this to get this. I'll just see if we can change the exposure there a little bit. But if you look in there is the spindle with the gear on and the worm on the armature that engages with that. Now, there is very little play or leeway between the end of that bearing and that disc. In fact, you can probably see how close that disc is to that spindle. And when we've dismantled this for any reason, it's an imperative that there is no fouling at all between either of those components and that spindle gear at the back. Now, the same principle applies to the removal of that armature on this as on the 14, and that is to remove the bearing that is protruding the most to give you most room, but ideally leave the other one in position to act as a reference point. For if you remove both bearings, you have lost that reference point, and therefore life becomes a little bit tricky in that, well, you can find the point at which you've got clearance here, but of course that may, because of the change in relationship between that disc and that pad, that may mess up the speed calibration when you come to use the motorboard, the controller on the motorboard, simply because you may not have the movement there in order to gain the 78 position. So really, if you do happen to take out those two bearings, look for telltale marks on the actual bearing that will indicate where that bearing was previously fixed. It's going to be a bit tricky finding exactly that point underneath the head of that screw, because obviously you can't see it, but nevertheless it is a guide, and it's the only guide you've got. Following on from that, once you've got the bearings in the position approximately you think they are okay, just test the speed there, the freedom. You should take little movement to spin that disc and move that spindle. Now, there is an additional problem with motors like the 50, and that is that instead of having a hole centrally placed, as was the case in the number 14, it is placed to one side. Now that is so we've got a little bit more adjustment of in and out of the spindle gear there. We can move that worm backwards or forwards in relation to that gear, and up and down, as it being circular, as it moves out it will also move down, and as it gets to the bottom of its movement it will obviously start to move in again. So we've got adjustment of the contact between that worm gear and the gear on the spindle. Now, for that to happen correctly, both of those bearing holes must be in line. And to be honest, the only way I know of doing this is trial and error. Set it first of all with both of the holes on the outside, so that worm is as far away from that gear as possible, and then slowly, by trial and error, move it and test it and spin it by hand, and making sure these two are locked off. If there's free movement there, try it by a couple of winds or so on the motor to get the actual spring moving that disc under its own power. You're trying to find it. You can do it by ear, you can do it by sight. You're looking for the point at which the sound is the sweetest, the movement is the easiest. But in no circumstances start with those bearings having the hole on the inside so that worm is tight up against that gear. It isn't going to be there. Start on the outside and work up and down from that outer position. When you find it, put it all together and calibrate the speed on the motor board. Okay, so just before we leave the video, I just wanted to mention one or two kind of general points. The first was to point out the location points on HMV components when it comes to governor armatures that prove useful. Here you can see this is a governor shaft, and they've kindly put a little indentation. This means I can take off the governor assembly with confidence, knowing that when I put it back, I've got that little indentation there to locate exactly where on that shaft that should go. Similarly, when it comes to removing the armature from the bearings, they have one bearing that has got a little groove in it, and that means that I can always get that back in its correct location in its pillar, knowing that then I've got a reference point for the remaining assembly of the governor armature. So that's very useful. Sadly, you don't get it with Garrard motors, which does make life a little bit difficult when it comes to them. The other point about governor armatures relates to any governor armature on any motor, and that is when you've got the motor out, do check whatever screws are used for fitting the various components of the governor assembly together. In this case, on an HMV motor, you can see that there are screws there that hold the springs onto the governor assembly at that end, onto that bush, I suppose you'd call it. They're at both ends, and there is one screw that fixes the assembly to the governor shaft, and we just saw on that governor shaft exactly where that's located in that indentation. Underneath, the springs are riveted to the weights, and there's not a lot you can do about that. If it's loose, you could tap it with a hammer and see if you could tighten that up, but those must be firmly fixed on the springs. When it comes to other motors like the Garrard, you see slightly the other way around. Here they've screwed the weights in place on the springs, but at the other end they are clipped. Those springs are clipped on and not screwed on for those little brass components at each end, that little bush, and at the other end the disc. Do check them. Check the clips that they're tight, check the screws that they're tight, check the screw that fits that assembly onto the shaft, that itself is tight and there's no movement. And finally, one last check, set the whole thing in motion and watch the pattern that's created by the spinning weights. It should be nice and circular and in balance, with nothing actually looking untoward or moving out of position. No vibration. They should spin evenly. Some people kind of use the point of a pencil at the extreme that they are seeing as the spinning is happening. Careful you don't get your pen locked into the springs or anything, or cause any damage that way, but just indicating where the extreme point is and making sure that each weight as it passes is passing that point. Just checks on the smoothness of that. If there is anything obviously that can cause vibrations within the motor. And the last thing about the governor assembly is keep it lubricated. Now, lubrication on the pad, on the disc, on the shaft itself that the armature is going to, the governor assembly is going to ride up and down, are important. So keep those lubricated. And it's important what you lubricate them with. Do not use 3-in-1 oil. Over time it becomes sticky, and particularly on the disc and the pad, that stickiness will lead to wow and flutter. You will actually hear it when you play a record. It will warble and sound quite horrible. Instead of 3-in-1 oil, I use Singer sewing machine oil. Sewing machine oil, a light oil, that will keep that nice and free and lubricated. So there we have it. That makes 2 videos now dealing with Garrard motors, and no doubt there'll be much that has been omitted. I've tried to cover the major variations that we come across using the 2 examples of the Garrard 14 and the Garrard 50 in this particular video. Although how many motors Garrard produced, goodness only knows. How many variations, I don't know. So no doubt we have scratched the surface, but I think we've covered some of the main elements. Certainly the biggest problem with Garrard motors is concerning the governor armature, and you've seen me and with the Garrard 14 how I did that with a very dicey system of manipulating that armature to get into the right position. A much safer method has been shown in this video, where we do it by trial and error. I'm always intrigued to find out which system Garrard actually used themselves. I can't believe they did it by trial and error. They must have had some form of system that allowed them to get it an effective and efficient running of their motors without recourse to move a bit and test it, as tends to be the case, the safe way that we as restorers would do it. Nevertheless, that remains a question that for me is unanswered. If anybody knows the answer to that, do let me know using the contact form on the greyhammerphones.co.uk website. Nothing else to say apart from that. I hope you enjoyed it. I hope it's proved useful, as I hope all these videos prove useful, and maybe you'll come back and see me some more sometime. Bye bye.